Drawing chair form cyclohexane and understanding chair flips. One thing that a lot of people struggle with when they first start organic chemistry is drawing the cyclohexane in the chair form and in seeing what happens when we do a chair flip. So I want to look at a couple of ways, or at least one way, that we can draw these structures. And we're going to start off by drawing a pair of interlocking lines like this. And you can call this a backward 7 and a sideways L or something like that, but they're two angles that are interlocking. We're going to do the same thing for the chair flipped form, except the orientation of the interlocking lines will be different. In the original chair form that we were drawing, the interlocking line on the bottom is pointing down to the right. On the chair flip form, it's pointing down to the left, and likewise the other one is pointing up and to the left. This is pointing up and to the right. Now we simply connect the ends of our two interlocking angles, and we have our two chair forms. I want to look at what this means and what this looks like in 3 dimensions so that we can see where the axial and the equatorial groups go. If we look at just the carbon skeleton, one of our chair forms looks like this, and the other one looks like this. And rotate it just a little bit. If we want to visualize where the parts of our chair come from, I can show you the two interlocking angles that we drew initially. This right here is right here. This over here is over here. And likewise over here we have this. And over here we have the other interlocking angle. I want to look at adding the hydrogens now, or in the case of substituted cyclohexanes, the non-hydrogen substituents. And when I do this, I always start with the axial groups because they're the easiest to see. And I'm going to start with one. I'm going to pick a carbon that's pointing down on both of them, and I'm going to draw the axial group, which is also going to be going down like this. And the thing about the axial hydrogens is they alternate. So if the one on this carbon is going down, the one right next to it is going up. So I'm going to fill in both of those. And I'll fill in those on my models down below as well. I'm not going to label these as hydrogens right now because it'll get a little bit too cluttered if I do that, but we need to realize that if I don't have an H listed here, these are not H's, they're actually CH3s. I'm going to go in and fill in the rest of my axial groups using the same process I did before, alternating down, up, and so on, so that I get structures that look like this. Notice down, up, down, up, down, up, and the same thing here, up, down, up, down, up, down, and on my models down below, also alternating. This broken line right here means that this group is in the back and this is in the front. Now we need to draw in our equatorial groups, and when we do that, there's always a temptation to draw the equatorial group straight out like this in the equatorial position, or straight out here in the equatorial position, but actually it's not straight out. And the rule that we use to figure out how to draw this is that if our axial group is going down, our equatorial group is going to be slanted slightly up. So this is going down and this is up just a little bit in the equatorial position. And we do the same thing on the other model. The axial is down, so the equatorial is slightly up. And we can fill in the same thing on these models down here as well. Now for the axial carbon that has an axial hydrogen going up, like this one or this one, the equatorial hydrogen goes slightly down. So when the axial goes down, the equatorial points up. When the axial is up, the equatorial points down. Up, so slightly down. And we can fill in the same idea, the same concept on this carbon, on this other chair form as well. And we can fill in the rest of our equatorial hydrogens using the same thing. This is up, so this would be down. This is down, so this will be up, and so forth, to get our cyclohexanes with all of the groups drawn in. And I'll fill in the equatorial groups on the models below as well. The last question that we need to answer is, where do our groups go when we transfer from one chair form to the other? In other words, where does this hydrogen end up when we flip to this chair form? And in order to visualize that, I'm going to color some of my atoms. So I've colored this atom red. And two important things to remember when we're trying to decide where this atom ends up in the chair flip form. Everything that was equatorial will be axial when we flip the chair. Everything that was axial will be equatorial. So the axial and the equatorial interconvert. And if an atom was pointed up, we should still have it pointed up in the flipped form. And if it's pointed down, it should still be pointed down in the flipped form. So in my chair flipped form, this was equatorial and up. Now it's axial and up. I could have picked any of these axial hydrogens to mark. I decided to pick this one. Let's look at some other atoms. I've chosen this atom, which is axial and up, so I know that's going to end up equatorial, and since it was up here, it's still going to be slanted up in the chair flipped form. So it's going to be this atom right here. Why did I pick this equatorial hydrogen and not, say, this one? Well, because these two groups in this original structure were 1, 2 with respect to one another, so they're still 1, 2 with respect to one another. If I pick one more atom, say this one right here, which is axial and up, and it's also 1, 2, 3 in a 1, 3 relationship with the carbon containing the green hydrogen, when I draw it on my chair flip, it's going to be equatorial and up, and still 1, 2, 3, 1, 3 with respect to the carbon with the green atom. If I fill this in on the lower models, equatorial and up goes to axial and up. Axial and up goes to equatorial and up. And likewise, axial and up goes to equatorial and up. And note that the blue sphere here was 1, 2, 3 from the green, and 1, 2, 3, 4 from the red. Still 1, 2, 3 from the green, and 1, 2, 3, 4 from the red.